Hi, I'm Colin Walls, and I'm here to talk about embedded software again. Today, I want to look at a feature of the C language which is particularly pertinent to embedded developers. And that feature is the volatile keyword. My American colleagues would say volatile, but I'm going to stick with the English version, volatile. And this keyword has been in the C language ever since the very early days of the language, and is particularly of interest to embedded developers for reasons that we will see. Now let's have a look at how it's used and what it means. Imagine you have some code like this. Two simple assignments where the data source in both of them is the variable x. Nothing wrong with that code. It's something we'll write all the time. Now, if we do not do anything about it, a compiler will probably do some optimization, and the resulting instructions will look something like this. So what happens is the value of x is copied into a register, and that copy is used for the subsequent operations. All of that's absolutely fine. Unless the variable x is special in some way. Special in that it might change in an unexpected fashion. That might be because it's an I/O device where the status of the device might change between those two assignments, or it might be a variable which is shared with another execution thread, which likewise might change between the two assignments. So how do we stop the compiler performing this optimization? Because that's what we need to do. The answer is we declare x as being volatile. Now, volatile is just a qualifier to the declaration. And so all we have to do is when we declare x, just put the word volatile in front of it. Easy, job done. However, there are two complications associated with volatile. One is relatively simple to address, and that is the question of syntax. The syntax is quite straightforward. You simply add the qualifier to the declaration. So we start with this declaration. Here we have a pointer to int, and it's a pointer to a volatile int. So pi1 is a pointer to a volatile int. Here's another declaration. Here, pi2 is a volatile pointer to an int. Where the int isn't volatile, the pointer is. So it's only a subtle change, but it does make a big difference. And of course, the last possibility is this one. Here we have a volatile pointer to a volatile int. I find it hard to imagine really wanting this in a real situation, but I suppose you could have a shared buffer or something, and that could contain a pointer to somewhere else in the shared buffer, and these things could change. So maybe it is reasonable. Certainly syntactically, it's perfectly okay. The other challenge with volatile is not so much a challenge, but a limitation which isn't always very obvious. And that limitation occurs when we are writing code in a multi-threaded environment, using a real-time operating system perhaps, or maybe just using code which is a main thread with interrupt service routines being executed. So imagine we have this code. We have a variable, volatile, called x. We've initialized it to something, we do some stuff, and then we increment x plus plus. What could possibly go wrong with that? Well, what code gets compiled for x plus plus? If it's a volatile, then we know the compiler will generate code which will extract the value of x and then increment it and write it back again. Great. What if there's an interrupt between those operations? Well, the compiler doesn't know anything about interrupts. He doesn't know anything about multi-threading and so forth. So the volatile keyword doesn't help you here. It will work okay if that particular CPU has an atomic increment instruction. So something which will increment a memory location on one instruction cycle. But that's relatively unusual. Normally a compiler will read x into a register or something, increment it and write it back again. So in the multitasking context, you need to protect x in the way you might do with other resources. So you would protect it using a semaphore, or surround the increment with a disable interrupt, re-enable interrupt, that kind of thing. Standard real-time behavior. The key thing is that volatile isn't doing anything to help you here. It would be kind of nice, I suppose, if the language had a keyword that said, shared with other threads or something like that. But the C language has no knowledge of multi-threading, and it doesn't look like it's going to get it in the very near future either. So that's volatile. Most of the syntactical information is the same as const, which is another keyword, but maybe we'll look at that another day. So I hope you found that helpful. The volatile keyword does cause some confusion. It didn't even occur in the early versions of C++, but it is there now. So you'll find it in almost any code written for an embedded system. So thanks for listening today. Do tune in next time. Until then, bye for now.